Okay, first thing, every circle has a center. Okay, that is also how you name us. Like we always name a triangle by its vertices, right? Whatever its vertices are, that's what I call the triangle, triangle ABC. Circle doesn't have vertices. So instead, I call a circle by its center. So whatever the center point is. So this circle right here, I would name circle C. Name a circle by its center. Okay, I name a circle by its center. Since it doesn't have any vertices. All right, here are the three parts I'll introduce to you. Again, you probably heard of two of these. From the center to a point on the circle. So everyone see this segment right here. One point is the center. The other point is somewhere on the circle. Anybody, we've heard of that one before? That's called the radius. Yes. So this part right here, from the center to a point on the circle is called the radius of a circle. Yep. All right. The next one is if you double a radius, and now a line segment that goes through the circle, but look at the two endpoints. Now they're on the circle. So the endpoint here and an endpoint here, but it's got to go through the center. If it goes through the center, that's called my diameter. Yeah, good. Diameter. And then finally, what if the two endpoints are on the circle, but it doesn't go through the center? Like it's got to go through the center to be called the diameter. If it doesn't go through the center, anybody know that one? That was the one I thought maybe you probably didn't know. So it doesn't go through the center. Drop some knowledge, anybody? All right, ready? Chord. It's called a chord. C-H-O-R-D. Chord. So it's a line segment that doesn't go through the center. So everyone see how all three are different right now. Radius, one of the points is the center. Diameter goes through the center, and a chord does not go through the center. All right, all good. All right. Here's what I want to focus on today. What's called the circumference. Circumference. You guys heard the word perimeter. You know what that is? Add up all the sides. Well, there's a problem. A circle doesn't have sides. So instead, what we say, the distance around the circle is called the circumference. Circumference. That's basically the perimeter of a circle. It's called the circumference. There's two formulas for it. You could use C equals pi d. What do you think d represents? Yeah, what we just talked about. That's the diameter length. Or you can use C equals 2 pi r, where r would be your, what did we just talk about on the last page? Starts with r. Okay, got that already. Radius. And pi, make sure you can locate it on your calculator because we may need to use it in some problems. Everyone see it right above your caret? Everyone see pi, 3.14, da-da-da-da. All right, that's right above there if you ever need it. All right. You pick which one you want. All right, I am not going to force you to memorize both. You do if you like C equals pi d or C equals 2 pi r. It's up to you. I'm going to, for classes anyway, I'm going to use pi d. All right, I'm going to use pi d because I always think, I forgot who taught me years and years ago, coffee pie donuts. Anybody seeing that? Coffee pie donuts? Yeah, you'll like it. You just don't want to admit it. It's fine. So that's what I use. I use C equals pi d, but if you want to use 2 pi r, use 2 pi r. All right, so let's find the circumference of this circle here. We'll assume this point here is the center. So what is 16 right now? What am I giving you as like 16 units? What's that called? 4. Good job. Yep, I called in one kid that's not here. 5. What's that called? That's the radius, right? Okay, so could I use 2 pi r because I have the radius? Yeah, but again, I told you guys I'm going to use C equals pi d. So C equals pi. Now, if the radius is 16, how do I find the diameter now? What do I need to do to that radius? Ooh, 11? Double it, exactly. So 16, double it, I get a diameter of 32. Now I want you to pay attention to the directions. Leave your answer in terms of pi. What that means is, in your answer, leave pi, pi. Don't go to your calculator and type it in. So my final answer here, I don't like the pi in front, 32 pi. That's in terms of pi. That means have pi in your answer. Don't go to your calculator. So the circumference, 32 pi. Everyone's good. That's a nice, easy, basic one for us to find the perimeter or circumference of a circle. All right, let's move it. Let's keep grinding here. Find the diameter and radius now to the nearest hundredth, rounding directions, right? Rounding, nearest hundredth, if the circumference is 106.4. So I'm giving you the circumference, you provide the diameter and the radius back. So again, I'm going to go to my formula. Circumference equals pi d. But now, where's that 106.4 going to get plugged in for? 5, where's it going to get plugged in for? Yep, circumference. So everyone, here you go. 106.4 equals pi d. It's asking me to solve for the diameter and radius, so let's do diameter first. How do I get the pi out of there? How do I get the pi out of there? 9, use your algebra. How do I get the pi out of there? Divide by pi. So I'm going to divide both sides by pi. D equals, I'm going to go to your calculator. We just discussed where that pi button is now. 106.4 divided by pi. Keep that number in your calculator too. Keep that number in your calculator. So go ahead, hundredth. So 2 numbers after the decimal you should give me. What's the diameter here? 1. Anna, what's your diameter? 33.87. Yep, 33.87. Now, when I go to find radius, first, just tell me what do I need to do to the diameter to get to radius. Just tell me what to do, and then we'll talk exactly. 12? Okay, divide it by 2. But here's what you got to divide by 2. The whole calculator display right now, the whole decimal in your I don't want you to divide this by 2 because this is rounded. I want you to divide the original number by 2. So that's why I said keep it in your calculator. Divide by 2. And how about your radius now rounded to the nearest hundredth? 4? I know, I got it. 9? Good, 16.93. So just make sure when you're dividing by 2, or if you're going backwards and multiplying by 2, it's got to be the original display in your calculator you're doing that to. All right, good work. Any questions there using circumference? Because I'm just going to get a little bit more involved every time. We're all good? All right. Let's see what you got. Son of, not the day I want this. The worst first day of the hardest unit. Good, yeah. Okay, here we go. All right. Ready to go? Yep, laugh it up, kids. Laugh it up. Laugh it up. Oh, hold on. Nope. All right, back to business. A square with a side length of 9. New vocabulary term. Inscribed. Meaning this square is inside the circle, but each vertice of the square has got to be touching the circle. All right, so here we go. Can we draw a diagram for this? So let's get up here's my circle. I have a square inscribed inside it. So the vertices are all touching the circle. So I need to blow this up. So that right there, not good enough. What I have up there, right? The vertices have to be touching the circle. There we go. And we know each side length is 9 inches, right? What's the circumference? All right, well, let's start with the formula. Ooh, how am I going to find the diameter here, right? That's our problem. I need to find the diameter of this circle. Well, let me just draw a couple in. You don't draw it in, though. All right, I know, let's say that's the center, right? So this could be that could be, I don't think that's a diameter, but I don't think I'm going to find it, right? Because everyone agrees it's not 9. All right, it's not, that's not going to work. All right, what if I draw one that way? Same problem. Can anybody find a diameter to draw in that maybe I could have a shot at finding? Remember, all the sides in the square are the same, so 9, 9, 9, 9. That's not going to cut it. That's not going to cut it. Is there anything else, Nate? What do you want me to draw in?
Diagonal of the square.
How about this? From here to here? How's that look? Okay, well, let's talk. How are you going to find that diameter? Remember, this is a square. Now I'm bringing in some quad properties. What else do you know about a square? Let's keep going. What else do we know about a square here? I know that's 9. This is the only thing I'm going to give you. That's 9, right? That side. And what else about a square?
You could do Pythagorean theorem.
I need a right triangle.
It's a square.
Oh, it's a square. So all the angles are right angles. And if I have a right triangle here, I can use Pythagorean theorem. Everyone, yes, to find the diameter. All right, so here we go. 9 squared plus 9 squared equals c squared, because that's my hypotenuse. (81 plus 81 equals c squared. What's that, 162? What do I still have to do on both sides? Take the square root. We're in above average math, though. We're in above average math. They tell me I don't want that decimal on your calculator when you take the square root of 62. I want to break that down. All right, I want to break 162 down. So let's try to find the biggest perfect square. 4, 9, 16, 25, 36. That goes into 162. And it's already on your paper. Anybody saw our previous step? What is that biggest perfect square? 81. Hey, look, right up above, right? We added it twice. So 81 is the biggest perfect square. What do you got to multiply it by? 2. So that diameter will be square root of 81. 9 square root of 2. All right, look at the directions, though. I didn't talk about this yet because this was tough enough. Find the exact circumference. Exact circumference, that's another name for leave it in terms of pi. So no decimal, just leave it in terms of pi. Get exact as you can, and that is exact as I can. Leave your answer in terms of pi. So leave pi in your answer. So we're good now. So circumference, 9 radical 2 was the diameter, times pi. Again, just please make sure the pi is clearly outside the radical. So that's exact circumference right there. No decimals, no nothing. All right, questions, comments? All right, we got 2 more with this one together, last one on your own. Center of a circle Q has coordinates 3, -2. Circle Q goes through R. What's the length of the diameter? All right, let's get a visual of this, right? Go ahead, set up a graph for me. Let's set up a graph. God, I'm so bitter right now. It's going to take a while to get over that. So cocky, too. And it goes through 7, 1. All right, let me give you a better visual here. And I'm not going to ask you to get out your compasses and waste time here. But here's the center, right? The circle goes through R. So here you go. Here's the circle. That's pretty good, I know. So how can I find the diameter? Hopefully that helped a little bit. Hey, if I connect Q to R, what's that called? If I connect earlier today, what's that called? If I connect Q to R, what do we got here? 1. Anna, what's that called if I connect Q to R?
Radius.
Radius, right? If I connect Q to R, that's the radius. How do you find the diameter if you have the radius? Because that's what I'm asking for. How long is the diameter? So if I know the radius, how can I find the diameter? 3?
The radius is half the diameter.
Correct. So all I would do is take the radius and double it. Can you guys help me find the length of the radius so I can double it? What am I going to need here?
Distance.
Yes! Finally, yes. Distance formula. And then I'm going to double it. So D equals... So go ahead. See what you can do with the distance. Plug in 3, -2, and 7, 1. X is subtracted, Y is subtracted, and then we're going to have to double it at the end. We will double it at the end. Whew, got a lot to catch up on, brother. Should begin out radius is a length of 5. We okay there? Square root of 25 when you do it. Because you should get some type of 2 squared here with your x's and some type of 3 squared here with your y's. Remember, hey, another reminder about distance. These numbers here should never be negative. Okay, I'm sorry, not these. These numbers here, after you're done squaring, should never be negative. Okay, so after you're done squaring, they should never be negative. All right, so if my radius length is 5, how about my diameter then? Diameter length. What do you got? 13? 10 units. Good work. Okay, so all that problem was noticing that I gave you the radius and I needed to find the length and double it. All right, you're on your own for the next one. See what you can do. Oh, and then it gives me a shatter. Just smacking me in the face right now. Smacking me in the face. So find the circumference, leave your answer in terms of pi. That's a rectangle, everyone. That's a rectangle. Leave pi in your answer. Leave your answer in terms of pi. We talked in the square problem, the best diameter to draw in is the diagonal of the figure, which is right here. So 6, 6, 8, 8. How did you find that diameter length? 13, how'd you find it? Pythag, what did it look like there, Charlie?
6 squared plus 8 squared
Equals?
100.
Okay, I'll get there. I'm just going to put c squared because I don't know. Getting ahead of me. So, yep, I get 100 equal to c squared. So how long was your diameter? 10. And then I just plug it in. Please don't put pi. Pi 10 is correct, but it's like, hey, x3. Who says that? All right, we say 3x. So 10 pi. And again, I don't care about units. I got to fight other battles. All right, questions there? Okay, look, I'm sticking to my word with nothing to do at home, but I'm not going to waste this last 14 minutes here. So here's what I want. Draw a little line across wherever your work was. Grab a textbook and you go through as many problems as you can up into the bell. But whatever you don't do, you're not responsible for. Hey, please take a peek up here for the answers, though. All right, I'm not asking you to get out your Chromebook to find the answers. If you want to use your Chromebook for textbook, that's fine. But I'm posting the answers up here. So please do as much as you can. And then I'll keep to my word. And the two Promethean mans, nothing tonight to do at home.